and today I'm going to be talking about Odin, a measurement platform used across Microsoft to support CDN and network operations. Currently, Odin makes billions of measurements a day, and we've used them to speed up connections for over 25% for users in some countries. So I'll first start with a quick overview of a CDN. So we want low latency service for all clients. But if content is deployed in a single location, distant users are going to have poor performance. So the strategy used by a CDN is to deploy front ends, which are co-located clusters of servers around the world, and then to direct users to a nearby one. And this is the same strategy that Microsoft uses in its own CDN. So let's first look at an example where we need to make some change to our CDN, but it may impact an application's performance. So we'll take a hypothetical Microsoft newsfeed application, and they've got users all over the world, and they're currently served by our CDN, but say only over IPv4. And then there's a new requirement that comes, and now the newsfeed app needs IPv6 connectivity. And so the first thing that the newsfeed team is going to ask is, how is this going to impact our performance? And the answer is, we really have no idea. So IPv4 and IPv6 routing on the internet is often completely different, and especially if you're announcing new or more specific prefixes. So we need to understand the performance impact of a CDN change, but it's difficult to evaluate on a global scale. So during this talk, I'll show you how Odin can be used to evaluate changes like the IPv6 example easily and continuously as part of routine CDN operations. We can also do this safely, so we don't need to touch production traffic, and we get coverage of the users we actually care about, which are Microsoft users. This allows us to understand the impact of a change before deployment so that we can address any issues. So evaluating CDN changes like the IPv6 example is just one type of measurement challenge that Odin helps to solve. So next I'll talk about other measurement challenges we face when operating a large CDN. So our goal is to deliver the best possible performance at reasonable cost, but the internet is diverse and dynamic. Microsoft exchanges traffic with tens of thousands of ISPs every day, and there are lots of factors that impact performance that are outside of a CDN's control, such as congestion, routing changes, and outages. So CDN network operations require constant insight into user performance. And internet measurement can provide this insight. So there are some common operational scenarios that require the insights offered by measurement. So for example, when services become unavailable or slow, we want to alert and reroute quickly. We also need diagnostic capabilities. So for example, if Comcast users in Seattle can't reach my CDN, can they reach other networks? And we also want to measure the impact of change on end users. So if I need to take a front end offline for maintenance, what's going to be the performance impact on that front end's users when they're directed to a different front end? So next, we'll consider whether or not existing solutions can meet our needs. I'll walk you through them and explain why they can't as a way to build up our key requirements. So the first existing solution I'll talk about is layer 3 measurements from CDN infrastructure. And layer 3 measurements are just things like traceroute and ping, and these will be issued from front ends to internet destinations. And the first issue with these is poor coverage. So previous work has shown that 74% of end users are unresponsive to these types of probes. The second issue is that layer 3 measurements fail to exercise important layer 7 behaviors such as HTTP redirection and SSL. But we need measurements to reflect the application layer because they impact user experience. So for example, if your HTTPS certs are busted, clients aren't going to be able to access your service. So layer 3 measurements don't meet our coverage needs, and we need to measure at the application layer. So can we just instead measure the existing application flows from using server-side instrumentation? And server-side instrumentation is a must, but it's insufficient by itself. And the first issue with it is that there's no explicit outage signal. So with server-side instrumentation, every time a client connects, you get a measurement. But when a client doesn't connect, it's difficult to detect whether this happened because of an outage or whether the client just didn't connect during that time period. And historical data tends to be much too noisy to detect things like transient or gray failures that may only be impacting a small number of clients. The second issue is that server-side instrumentation only shows you the current state of your network, but not the possible state. So if you want to explore alternative paths, you need to traffic engineer some amount of your production traffic to do that. And so unlike a lot of other large tech companies, Microsoft primarily serves enterprise users. And so we felt that using production enterprise traffic for internet experimentation was an unnecessary risk. So server-side instrumentation also doesn't meet our needs. So instead of passively monitoring at the server side, we need to be doing active measurements. And there are third-party measurement platforms that do active measurements, so let's look at those next. So third-party platforms are just companies that operate a set of vantage points on the internet, and they run measurements on their customers' behalf. So we worked heavily with nearly all of these, and they all have inadequate coverage. So at best, we'll see fewer than 10 measurements per day from 88% of Microsoft customer networks. So third-party measurement platforms overcome the limitations of the techniques I've talked about so far, but they fail to cover Microsoft's user population. So to summarize, the three existing solutions we've described fail to meet our requirements. But Odin does meet our requirements. And next, I'll discuss how Odin meets our measurement needs. So let's start with a Microsoft Web Store user being served by server A. And we work with application owners to embed a JavaScript Odin measurement client in the web application. So first of all, Odin is a client-side measurement platform. An Odin client can then issue a measurement to server A by sending a GET request for a tiny image. And we see that this image gets returned in 20 milliseconds. So Odin is an active measurement platform because it generates synthetic traffic for measurement purposes instead of passively recording existing traffic. And Odin does measurements at the application layer, so using HTTP or HTTPS. So after Odin issues a measurement, it then can report that measurement result to a report endpoint, where it gets enriched with things like, it gets enriched with metadata such as geolocation information, and then it gets sent to our analysis and alerting pipelines. So Odin supports both web and rich clients. So here we have a stock ticker desktop user being served by server B, and it performs the same measurement as the web client except to server B. So let's say our measurement to server B fails. Odin provides an explicit failure notification by having the client report the error to our backend. And this allows us to track availability and to look for outages. So our examples so far showed Odin collecting measurements to our application servers, but it also supports other types of measurements. So for this, Odin clients first contact an orchestration service, which returns a measurement specification. And the measurement specification is customized for the requesting application and the client. And so we show a minimized version here, but it contains things like target URLs and primary and backup report endpoints. So with the orchestration service, from a single location, we can measure many different Microsoft services in many different locations. So let's say again that our measurement to server B fails, and then reporting that failure also fails. And so since server B and the report endpoint are both hosted in Microsoft, any Microsoft outage may impact both of these. But we need to receive measurements even if Microsoft's network is unavailable. So to get around this, we deploy report proxies in third-party networks. So if sending the initial measurement report fails, the client will send the report to the report proxy, and then the report proxy will then forward that to our report endpoint, and in most cases circumvent the outage. So far, we've looked at how rich clients and external networks can enable true availability measurements. We deploy a similar mechanism for the orchestration service so that even in the case of an outage, we have measurements to issue. And there are also cases where failures may impact the primary and proxy report endpoints. We've performed several evaluations of these, and please see the paper for more details. So now that we've seen how Odin works, let's look at some real examples of how we've used Odin to support our operations. So Azure is Microsoft's public cloud platform. It currently has 38 regions. And customers generally deploy their services in a subset of these regions. And we use DNS to direct users to the lowest latency region. And we've recently updated our process for finding the lowest latency region for a user to use an Odin-based technique. So first I'll do a quick overview of how CDNs use DNS. So we start with an end user who's interested in going to www.cdn.com, and so they send a DNS request for that IP address to their local DNS, or LDNS 1234. And if the LDNS doesn't have a cached copy of that, it will forward the request to the authoritative DNS for cdn.com. And the authoritative DNS has a mapping for what region it thinks will give the best performance for the users behind LDNS 1234. So in this case, it returns the DNS record for region A, which then gets forwarded back to the user, and then the user can connect to region A. So next I'll talk about our previous approach. So offline, we ping all LDNSs from all regions, and then direct the LDNS to the region with the minimum ping. And this approach has a couple limitations. First is that most LDNSs don't respond to ping. So previous work has showed that only around 15% of LDNSs on the internet are going to respond to unsolicited probes. The second issue is that ping to LDNS may not reflect client performance because it makes some assumptions about the proximity between clients and their LDNSs, both in terms of geography and topology. So next I'll talk about Odin's approach. So Odin has clients all over the world, issuing latency measurements to all regions. Odin also implements a measurement technique so that it knows what LDNS a client used when it made a measurement. So Odin knows all the clients served by an LDNS. So with this, we're able to associate the client-to-region measurements with the client's LDNS, compare median latency towards each region, and then select the lowest latency region as best. So this figure shows the percent of latency improvement from using our Odin-based mapping technique. On the y-axis, we have the percent improvement at the 75th percentile, and on the x-axis are Microsoft high traffic volume countries. So we see that 10 countries see 10% or more improvement in latency. And 3 of these, Japan, Italy, and Spain, see over 25% latency improvement. So our Odin-based mapping technique substantially improved performance for Azure Cloud customers. So next, I'll talk about using Odin to identify outages. So sometime last year, users in AS 1759 in Finland started seeing errors when measuring to our Helsinki front end. They also saw errors trying to report these measurements because actually the report endpoint is hosted in the Helsinki front end. Clients were able to proxy the results, so we were able to detect the outage. And the figure shows the full outage over time. So on the y-axis, we have availability, and on the x-axis are a number of hours. And you can see that around the 15th hour, there's a sharp drop in availability. So there's a number of possible explanations for this incident with different outage scopes. We need to quickly narrow down the problem because it actually impacts actual client traffic in addition to Odin measurements. So it may be that AS 1759 is having issues reaching many destinations on the internet. It may be that this is a total outage between this AS and Microsoft, or it may just be limited to the Helsinki region. It also might be that our Helsinki front end is just failing. So next, we examine measurements to an external measurement endpoint. And these are successful. So this suggests that this isn't a widespread issue with AS 1759. So Odin clients not only continuously measure their application front end, but also other Microsoft destinations, including an Azure data center. These measurements reveal that clients can still reach Microsoft. So this doesn't appear to be a total outage between AS 1759 and Microsoft. And next, we'll look at measurements from other ASs to the Helsinki front end. So for this, we selected AS 719, which is also in the Helsinki region in Finland. And these measurements are also successful. So this doesn't look like a front-end failure. The most likely explanation is that this is a regional outage between AS 1759 and Microsoft in Helsinki. And so by combining measurements between diverse sources and destinations, we were able to narrow down the work needed to mitigate. So to conclude, Odin is a client-side active measurement platform to support Microsoft CDN operations. We've been running Odin in production for around 2 years, and it's been deployed in key Microsoft applications, or end-user applications, and issuing billions of measurements every day. Odin overcomes the limitations of existing solutions. And we've shown how Odin improves CDN operations by examining how to use Odin to detect and diagnose outages, and also by looking at the performance improvements for cloud customers by using an Odin-based DNS redirection. So thank you for listening, and I'm happy to take any questions.
So in your last experiment or outage in Helsinki, was this basically troubleshooting manually or automatic?
So the data I've shown is independent of any of the systems that we've built on top of Odin for doing any kind of automatic traffic engineering or anything. So it was just for illustrative purposes. So Odin. So what I've shown is the data just from Odin's data collection.
So maybe my question is Odin just a measurement system or a correlation engine system that basically looks at all the data and okay, here it is.
Yeah. So Odin is just the measurement system, but it's the measurement system deployed on a global scale. And basically, the design is that we build what we do is we build sophisticated applications such as traffic engineering or things like that on top of Odin. But it isn't a system for doing this kind of correlation.
Okay. Yeah. Thank you.
Shankar from AT&T Labs. I'm curious how Odin can work with third-party applications. Does it mean that you have to embed the marker that you introduce into those applications? Can you leverage other existing signaling mechanisms that most applications have into Odin? How flexible is it to ingest those information coming in from third-party apps?
So, yeah, right now for third-party apps, so this is a pretty standard sort of, if say take a web app for example, this is a pretty standard mechanism that actually does the measurement, and I think a lot of what probably might not work immediately with the third-party applications is sort of all the intelligence we've built into the orchestration service, which is really the part that lets us control and distribute measurements, on a global scale. So I'm not sure what third-party, if there was a particular one that you had in mind, but maybe if I had a little, with a little more context, I might be able to give you a better answer. Yeah, thanks.
Hi, I have a question from Rich from Microsoft. Going back to your motivating example about IPv6, so what was the answer? I mean, is IPv6 better or not? No,
it's that. Basically the answer is that if you announce new IP blocks for IPv6, so let me back up a little bit. So for most services, they've been announcing the same set of IP space on the internet for a pretty long time, but that IP space doesn't work that routing doesn't automatically work how you want it to. There's basically a long grooming process is generally what we call it. And so you basically have to contact all the ISPs that aren't routing correctly, and that's a very manual process. So with the IPv6 example, it was to illustrate that if you do this, you can't it's not safe to just switch over to IPv6 and to do this automatically. It isn't going to match your IPv4 performance.
Yeah.
And so you want to know about this before you flip the switch on production.
Yeah. So what's the answer? How much slower is IPv6?
There's that. Yeah. There's no. I don't think it's that simple, to be honest. Yeah.
Hi, Ajay Mahimkar, AT&T. So I was wondering if your system is always on and collecting measurements all the time, or can you also kind of collect this more dynamically, especially during changes in the network? Maybe you can collect more measurements, try to normalize the data because there is diurnal patterns and things. So just before changes deployed, maybe get more measurements and then try to build a profile.
Yeah. So what we do is, again, we use exactly the orchestration service for this purpose. So basically, all that thing does is it reads configuration changes that we make. So we treat them as experiments, and so the system is always collecting measurements for experiments, but we tweak them as we need. Yeah. Thank you.
One more question.
Hi, this is Venkat. I'm a graduate student at MIT.
Hi.
This is a lot of data, and academics like us can only dream of getting access to this. So what can one do to get access to this data?
So yeah, so we're always happy to talk with people from academia. We work closely with with our collaborators at Microsoft Research, and so yeah, if you're interested in this type of work or the kind of data we might be able to collect, then I would say just come talk to us and we'll be happy to.
So it's accessible. It's not protected by customer privacy or.
So that's a sort of a different issue, and so this data isn't certainly isn't available for public consumption immediately, but I think we do take on research projects with academia. Yeah, thank you.
All right, let's thank Matt.